Hi everybody, welcome to Getting Started with Bluetooth and Golioth Connectivity. My name is Chris, I'm here with my coworker Mike. How you doing, Mike?
I'm doing well. How are you, Chris?
Good. We are going to be going over the exciting new advancements in Golioth in directly connected devices. Maybe we should give a quick overview of what we are actually talking about though. What
Yeah.
does it all mean, Mike? What does it all mean?
Normally, we're talking about Wi-Fi, cellular, Ethernet, thread, but this is not any of those.
This ain't that.
This is
Yeah.
Bluetooth, and most people don't think of Bluetooth having a direct pipe to the internet. And I certainly didn't think about that when I first had people asking us about it. At conferences, oftentimes we meet engineers who are looking for a solution to like OTA a Bluetooth fleet or to get sensor data from a Bluetooth fleet. And most of the solutions were have somebody with a cell phone and an app that connects to those devices, which is usually not going to work for like
Yeah.
industrial fleets, where let's say you have a cold storage and you're collecting temperature data from a large amount of places, or you have some kind of signaling fleet that is able to drive signage or turn on and off lights.
The one that I always think about is actually someone came to us and they wanted to monitor beehives, and it would have been very expensive to monitor each beehive. Like you have like 20 of them in an area. You don't need 20 cell modems to do that sort of thing. In fact, one cell modem and 20 Bluetooth things is great because they're also, you want to have them taking data all the time. They can talk back through a single gateway. But at the time, we couldn't support that because I think we actually suggested, what about 20 cell modems? It's like, oh, that's a lot more hardware. That's just, it gets up there, and it didn't really match it wasn't the right tool for the job in that case. So
But
it was
this week that
unfortunate.
all changed.
Right? People are abuzz about our new capabilities.
Ooh, a buzz.
A buzz. Anyways, terrible dad jokes aside, yeah. Now the difference is each of those. I'm just going to keep talking about beehives. Each of those beehives that has a Bluetooth monitor on it, it can talk back as though it did have a cell modem on it. Each one has its own cell modem, and that's because of things like pouch. And although my screen share died, I did have at one point the blog post up there. I'll bring that up again. Where is it? Bluetooth support is here. Yes, this one. That didn't work. Did that work? I don't think that worked.
So as Chris does that, so the point of today's live stream is we are going to start from zero and set up a working Bluetooth fleet by the end of the broadcast.
Yep, that's right. Yeah, and this one, this is the. I guess this is the. Sorry, this is the announcement. This is the getting started. We do have all the steps here, but we're gonna, yeah, like Mike said, we're gonna actually do it. Let's talk a little bit about gateways first. So we do have 3 different gateways. 2 of them are cellular, so this is one of them. This is the NRF 9160DK. You'll probably see this a lot in our existing stuff. We use this a lot. There's also the Thingy 91X. This is kind of a more productized version of this. It also has both of these have a Bluetooth chip on board. They have a cellular modem in control. There's a Bluetooth chip on board as well. But this one also has Wi-Fi, which is fun for locationing, and which we also enable through Golioth. And then the kind of the new one of the bunch is the NXP Freedom RW612. This one is also multimodal, Wi-Fi, Bluetooth, Thread, and Ethernet. So that's like another crazy amount of ways to connect. And we use it because it has both of those to be able to pass the Bluetooth pouches through. So we're going to actually go, and Mike's going to show downloading the precompiled binary. We have all the binaries available here, so that you can go, and you don't have to go and rebuild this. This is now an open source repository, but you don't have to actually go and build it yourself. If you're going to production, you should be building it yourself, but for just starting out, we definitely say just use the binary and get started like that. So Mike, you want to show how we do this sort of thing?
Yeah, so I think let's start off with the gateway itself. And so I don't think I need to show a down camera on this. I have here a NXP FRDM RW612 development board very cost-effective development board that has Ethernet. So I like it because it's very fast when I'm developing to, when I reboot it, it connects very fast to the network. But also has Wi-Fi, so and Bluetooth as well. So we need something that connects to the internet. So that's the Ethernet or Wi-Fi, and then talks to Bluetooth devices. So that's the Bluetooth on this. So we're going to be using this. Right now, I just have Blinky running on this. So if we look at a terminal, we can just see LED state is going on and off on this. And what we're going to do is head over to Golioth Bluetooth Gateway repository, and you can update this gateway for your device, change this however you want. But in my case, I'm just going to use the latest release. And you can see there are binaries here for this NXP Freedom RW612 or Nordic's 9160DK or Nordic's Thingy 91X. And also just the Thingy 91X, it looks like. I don't know, why are there 4 there? Because of the elves. I get it. Okay. So I've already downloaded this hex file, and I'm going to put it onto this device over here. Now, there is a little bit of magic for flashing this device outside of Zephyr. So I am using just this JLink file that tells it to load that hex. And I can just...
There's also directions in the GitHub if you want to use JLink Commander, you can also do that. So you go into JLink Commander and have the file local, and you just use a write file there.
That's right. All right, so we're flashing it, we're verifying it, and now we should see it running. There it comes. And it tells you immediately no credentials found. So we need to give some credentials to this device. And in this case, I'm just going to use PSK for this demonstration, although you should use certificates at production, which Golioth supports well. So I am going to start a new project for this called Bluetooth live stream. And I'm going to add a device, and I'm just going to call this one my Bluetooth gateway 001, because we're going to have lots of gateways. We'll have just one today. So immediately this tells us our device is ready to connect. It gives us a PSK ID and PSK, and that's what I need to feed into the terminal here. So I'll use this terminal command and for my PSK ID, and I'll copy my PSK. And then I need to reboot it. You could just press the button, but I'm going to issue the reboot command, and it comes back up here. It's going to fail to connect because it doesn't have an IP address yet. But wait a sec for the IP address to come on. Believe it or not, this is faster than cellular. There it goes. Now it should connect to Golioth. All right, so it says Bluetooth initialized, scanning successfully started. A few lines above it says Golioth client connected. And on my dashboard, I can see now that a session was established a few seconds ago. So we have a connection, and that's it. Like that's the gateway. Gateway done. So that's really nice. Good work to the Golioth from our team.
That we put in the blog post as well is that you have to have a Golioth account, but you can already see this thing is connected, and you've already with this you're showing a lot of that was basically the a lot of the steps that people would have taken with any device, regardless of connectivity type, right? So.
Yeah, that's right, exactly. And like I said, we use pre-shared keys here, but we could have used a certificate. And the nice thing about certificates are I created this device manually in the Golioth dashboard, but now for all of our Bluetooth nodes, you can roll them off the manufacturing line with a certificate preloaded on it, and you don't have to do anything. It will zero-touch provision itself on Golioth, and we're going to see that here today. We don't have, there are a lot of PKI vendors out there that you can choose from to go with. We have not set that up for today's demonstration, but you can easily generate these keys with like OpenSSL commands, which is what we're going to do today. So let's switch over to the pouch demo is what we're going to do. So that is at Golioth's GitHub/pouch page. And this pouch is a protocol that you can use on any device. This repository happens to be focused on devices running Zephyr, but if you have a device running something else and you follow the specifications of the pouch protocol, you can add it to your Goliath fleet as well. In this case, we're just going to build the example application right here. And there are instructions on how to do that. First of all, is just getting the repository and building it. So let's go ahead and do that. The device I have for this, is right in front of me. And that is this right here. This is a NRF52840DK board. Great for Bluetooth development. One of the many that we've connected to our fleets. So in my pouch directory, I think, let's see here. Yep, I have it called app. So I have a West build. There's the command right there. So I'm building for the 52840DK, and I'm directing it to the examples directory. So let's just go ahead and build that file.
As you're building that, I am dropping links in here, both for the blog post, the repository that Mike showed with the Bluetooth gateway, that's shared now, and then also pouch. So, and all this stuff is in that blog post as well. So,
excellent, thank you. All right, we built, and now we just.
Oh yeah, sorry. Probably have more time in between compiling and flashing and such.
Yeah. Let me just flash it really quick.
More color commentary as that comes, huh?
All right, so that's flashing. What? Oh, must be recovered. Can I just do that maybe? I think when you do, I did a full erase on this. And I think it always wants you to recover after that. All right, we're done. What were you going to say, Chris?
Oh, just about the idea of pouch in the first place. So pouch is basically a new protocol that we came up with at Goliath. It is one of our newer innovations that's enabling Bluetooth, but also other things in the future. But basically, that's where within the headers we talk about the encryption and kind of it's how we understand this data that we're wrapping up and sending through a gateway up to the cloud and then unwrapping at the cloud. That's why it's called pouch. So it is one of the big innovations, and like I said, there's more stuff we'll be doing there with different transports in the future.
All right, so we're done flashing, and if we look at this device, it boots up and tells us that it failed to load the certificate, and that's because we didn't give it a certificate. So for this example, the way we're going to give it a certificate is through the USB connection. We're going to write it to the file system on this device, but we don't currently have any certificate to give it, so I need to make a certificate. And in this case, I'm going to the Goliath docs. This is what they look like when you get there, and under connectivity, there is a public key infrastructure, PKI. That's what we're looking at. And we're just going to run these commands. So this first one is generating a certificate authority. And once we have that generated, we actually want to upload the ca.crt.pem file to Goliath. That is the public certificate. You want to keep the key part private because that can be used to sign new devices onto your fleet. So don't give that up to anyone. If you were using a more robust production PKI infrastructure, you would probably have the devices generate their own certificates and then send a certificate signing request to your PKI provider. And then you wouldn't have to worry about the private key because your provider would keep it safe. All right, so in my Goliath project on console.goliath.io, I'm going to go to this certificates tab and add a CA certificate. So I'm going to upload. So I'm in the pouch directory. It is this crt.pem. I thought it was .pem. Where am I? Okay, there we go. crt.pem. There we go.
Yep.
Open, add. All right, and you can see this one expires in 10 days. That's probably a bad idea if you're going into production. This is just for demonstration purposes. That was one of the settings when I generated it. So that is for the project to be able to recognize devices that have a device certificate signed with this CA, root CA. So now we actually need to sign a device certificate that we're going to give to this. So I'm going to go back to our docs here, and we're going to go further down to generating device certificates. And I'm going to run through these commands in order to do that. So that, and this one is where we need to do some customization. So you can see in here, we're setting up the common name. So this is what we're going to call our device. And I might as well call this my nifty node 001, obviously. And then I want your project slug. So I made a new project when I started this. And we're actually going to want to go to project settings and get the ID right here, this one. So I'm going to paste that in here and then let that generate. And let's see, that was this step. And then we need to actually sign it. And it's signed. Excellent. So now we have a whole bunch of files that we didn't have before, but they all end in PEM, which is like human readable. So if we do like the device certificate, which is public, so it's okay to show it, that is human readable, but we need to make a DER file, which is going to be device readable. And you actually want to get a reference. First of all, I should say there's no secret sauce. All of this stuff that we're doing is like very common OpenSSL commands. We happen to have them in our docs, but you can find them in many different places. So use the ones that you know and love. Under device authentication, we have these commands here to translate a PEM file to a DIR file so the device can use it. So I'm going to run these. All right. And now we have all the files we need. We need to send our DIR files to the device. So it said failed to load certificates, and that's because there are no certificates on this device. I need to close my terminal in order to load these because I'm going to use the same USB port. And interestingly, there is a Python command called SMP Manager that is great for loading things onto these devices. I think better than the MCU Manager. What did this do? This is weird. I already have it installed, so I'm not sure why it's giving me all this guff. All right. Now we want to actually look at the instructions here because they have instructions on how to load these. So right here, I'm going to load this file and I need to call it device CRT dir. And then I need to give it the port as well. All right. And it wrote, so that's excellent. Now I just want to do the same with the key file. So I'm just going to change these to key. And that wrote as well. And now I can load back up. And I actually want to do a reboot of this leaf node. And now it says advertising started. So it found our certificate and it is going to advertise, I think it's set by default every 20 seconds. Does that sound right?
That's right.
So
config,
remember we have our gateway over here already running, and now we have our leaf node, and our leaf node we hit 20 seconds, so it's advertising, it's beginning the Goliath uplink, and if we go to our project page where we only had one device before, we now have two devices. Woohoo! So not only do we have a device, but it is sending simulated sensor data, so you can see. Let's see, do I not have a pipeline? I think I need a pipeline for JSON. Does that sound right?
Yeah, just hit the blue, like you just see the blue button. Go back to where it was.
Oh, suggested pipelines. Oh, that's even easier.
The pipeline. This is a great feature that the cloud team put in.
Look at that.
Yeah, it's great. Because it's like there was data hitting the cloud that wasn't going anywhere because the pipeline wasn't set up, and it says, "Hey, we'll set it up for you." So it has saved my bacon a couple times. So good job, cloud team.
All right, excellent. That's a trick I hadn't used before. So let's see now if we have any data. Yep, there it is. So we got our simulated data, and since there isn't a separate temperature sensor on this board, it's just going to keep sending us 22, which is still interesting, but not as interesting as real data. So add sensors to your device. The other thing is you can see the uplink information here. Pretty sure you can't read any of this because it is encrypted. Does that sound right?
That is correct. You should not.
So this is
if you can read it, you're not encrypting it.
Yeah, these are the encrypted packages that are going
keys.
through.
So yeah, if you're looking at the so we're looking at the gateway currently, right? Yes.
Yeah, this is the gateway. So the gateway sees this pouch packet and sends it up to the cloud.
Right. Exactly. So the gateway does not have keys to your data, which means that it can't decrypt it locally. If you're setting up, so say you have a new device and you want to set it up on Goliath, and you do need something to show up on the gateway. Say you just wanted a gateway that's also displaying heart rate data or some other kind of maybe battery data from the device that's talking to it. Well, you can actually just send it in a different GAT message just to the gateway, and that can be unencrypted at that point. But anything going to Goliath up through a gateway will be encrypted. So it's the only way to do it.
And we should be seeing more data coming through, right? That is strange. I'm not sure why we're not getting more readings, but let's actually try the downlink. So there is also an LED on the board. And if I add a setting, built into this example is a setting called LED, and it's a Boolean for either being on or off. And let's start it on by default. And it will tell you this will affect every device in the project. And we should see on the device here, the next time it checks in, it should get a command to turn the LED on. So it's beginning uplink. And there, we got LED setting 1, and it finished for that entry. And I bet you won't believe what happens, Chris, if I set this to false. Waiting 20 seconds is the hardest part.
It is, yeah. And that is configurable as well. So that is a K-config. You can configure that.
Yeah, you can make it 10 minutes if you want.
That's right, exactly. And that's really so that you can, dial it in at your own power stuff. Mike, what happened?
Yeah, so you see I went to 0 when I set it to false, which is just crazy. So
you're not going to show us the camera even? Yeah, how do we know you're not just, have a fancy LLM that is blinking stuff on and off? I know it sounds silly, but blinking an LED from a terminal still does it for me, but doing it over Bluetooth from the internet is something real special in my mind.
So you can see the absence of LED right here. But if we change it,
tell me more. This is just Mike's finger. Oh, there it is. Nice.
There's the presence of LED. Amazing.
Yes.
So that's not the most exciting thing, but Chris has been working on this great piece of hardware here that we call the Teak board. So this is going to be running the same Bluetooth chip.
I was going to say, this board is nothing without the firmware that Mike has written. So this is
thank you.
A joint venture between Mike and myself and the entire Bluetooth team that made all this infrastructure possible. So,
you're so kind. All right. So I'm going to leave this one running because it's nice to have more than one. But this is the same chip. So this is an NRF52840 on this board, but it's connected to this fabulous LED matrix on the top of the board. And we're going to plug that in, and it will tell you that it already has a certificate on it, Teak 001. And the interesting thing about that certificate is when it is read by the gateway, we will see an error message. So let's see if it gets read here.
And why is that? Is it because it's on the wrong project?
We're going to go into it, yeah.
Yeah.
All right. There we go. So CoAP error 4.12 failed to finish device cert -5. Can you guess why we're having problems with this, Chris?
It's not allowed. It's not allowed to go to your project.
It's not allowed because I just generated this CA certificate, and I didn't sign the certificate on this Teak board with that same certificate, but I did keep that CA. So I can actually just upload a second CA to this device, and I put it in the temp directory. That's actually what we were looking at before. And it is CA cert.pem, and I can upload this one. And now I have 2 certificates. So you can have multiple different certificates. I think as many as you want. I don't think that there is a limit to it. Oh, and look at this. You can already see that this board has appeared on my dashboard. So I must have just gotten it up there in time. And you can see this one's also sending temp 22. However, the firmware on the Teak board has an additional device setting. So I'm going to add message.
It has two, I believe, doesn't it?
It does it have 2?
Arrow as well?
Oh yeah, it has arrow. I forgot about arrow. All right, so I'm gonna start with string though, and let's do This is a test of the Golioth broadcast system. This is only a test. And there it comes through. Is it mirrored on your screen? It's mirrored on mine.
No, it looks good here. This is, I think it's...
Okay, yeah, I think it's just the broadcast software shows me a mirrored view. But there is our message coming through. It came through the downlink and hit the device. So this ability to send and receive from the cloud is very, very crucial in extending your devices beyond the local area that they're installed in. But I think obviously the final part of it is you want to be able to update these devices remotely as well. And Golioth has that already built in with our OTA. I don't think we're going to show an OTA today. That might be a separate broadcast, but you can see under the firmware tab for this Teak that we did not report in. I'm surprised that we did not report a firmware version in. But we should have reported a firmware version in. So you do have firmware control under this packages tab. You can upload whatever binaries you want to send to a device. So this might be just the firmware that's running on the device that you can update over the air with, or it could also be like a machine learning set or like a graphic to display on a screen, or really whatever binary data you need to get to your fleet, you can add as a package. And then you can put your different devices into what are called cohorts. So you could have like, based on location, or if you just have a few that you want to test with, you can group them into groups of devices called cohorts that you can then roll out over-the-air updates to and send one or more binaries down the pipe.
Yes, that is super cool. And we actually have a video of that on YouTube currently, so we can link people. I'll link that in the chat as well, so people can see that. YouTube and on LinkedIn, I believe. So. Cool. Let's see, how do I find this link? Oh, yeah, I see our copy link address. There we go. All right, cool. This is the OTA video that's going into the chat now as well. All right, people should see that. Well, that's really cool. Mike, could we take a look at the code to see what it looks like to add a new setting, callback?
Yeah, absolutely. So maybe what we should look at is the Teak board that we were just looking at, since that has a few in it. Let's just get into here, and this does not look like the right I have checked out. No, this is right.
Yeah, MCU.
All right, here we go. It's the Teak pouch demo right here is what this one's running. And so you can see inside of this that there is a whole bunch of stuff, but really the important ones are where we've defined LED settings. All right, so you can see right here where the LED setting that we were looking at, which was just capital LED with a Boolean value, it's defined with this macro that is Golioth settings handler. We give it the name of the setting and then a callback function, LED setting CB. And that is a very simple fingerprint here, which is just a new value that's a Boolean. So in that case, we look at it and we log it out. And then we look to see if the device actually has an LED in the device tree. And if it does, we use that Boolean value to update it. So it couldn't be simpler there. With the message, LED message callback, so it's registered in the same way. We tell it this is a settings handler for a setting called message, LED message CB, and we just tell it the type by the pattern of the callback. And so this pattern is a pointer to a string, so a const char star, and the length for that string. And then we can just look, and in our case, we're going to store the string locally, so we bounds check it to make sure that it's going to fit in our local RAM, and then we copy it and log it, and then we actually scroll it out to the display. So like handling these is super simple. Same with like this arrow, we didn't actually show that yet, but it takes an integer value. And so the callback for it is just going to be, sorry, that's one too high. The callback for it's just going to be a new value that is a type of integer. So really easy to parse the settings that are coming back down from the cloud and make them do whatever you need in your application.
Awesome. Yeah. The ability to add a new set. I mean, that feels like the kind of the first thing people are going to want to be able to do is just tie it into their own logic, their own board, whatever they're working on, to customize it there.
Yeah, as far as the pouch, I haven't done a ton of hacking on the pouch stuff yet. I've added my own data to it. Pouch event handler. So this is where the magic happens on sending the simulated temperature sensor data. In fact, you can see right here, we're just hard coding a JSON value. But you basically get this event handler fires every time the device is connected to a gateway in order to send something up to the cloud. And so you would just be able to format your data however you want, use this write entry in order to choose a path for where you're sending that data. And then you choose your type. It could be JSON, CBOR, or octet stream, binary data. And then this is the data to send, the length of the data you're sending, and how long to, this is some timeout, how long to wait in trying to write this to the uplink.
Yeah, and if people need to see other examples of this sort of thing, especially, I guess a lot of our stuff is transitioned over to be CBOR based instead of JSON based, but we do have a bunch of historical examples as well in our reference designs. Kind of just this formatting, the formatting of data and setting up JSON. It's kind of it's not native embedded kind of thing. A lot of people are kind of have to learn the JSON and or CBOR ways, but there are a lot of examples out there.
Yeah, we have examples on our page. I do prefer using CBOR. I almost always start the first one with some simple hard-coded JSON like this, just because it's pretty easy to read and see that you've got it going right. Like you when you start working with CBOR and something's wrong, you then need to go on the debugger and figure out the CBOR in memory, and then paste that into a web-based decoder tool, and then look and see what you have
calculator
wrong.
Effectively, it'd be I think for JSON too, I always forget to close the curly brackets or escape a quote or something like that. So it's good to have those tools.
Yeah, I'm king of the off by one error on the length, and so then you don't send the closing curly bracket, and then the server is just like, nah, I don't know what to do with this.
Right. But as we saw, I mean, if you're sending it to, say you're sending CBOR instead of JSON, and your pipeline set up the other, it'll tell you now. So that is
very cool.
Nice. Yeah. Well, that was a great demo, Mike, and seeing all this stuff kind of in action really drives home kind of the abilities of the platform, and it's not 0 steps to get it set up, but it's fast. I mean, obviously that's very fast. So we think that people, definitely, if you're following along, if you want to try this yourself, we definitely recommend trying the hardware that we show, at very least for the gateway. We have other hardware, like Mike mentioned, that we've tried out. We are tracking that on our forum. So if you wanted to try out a different vendor, we've tested 6 different vendors that are in Zephyr. So Scilabs, ST Nordic, Renesas, Espressif. Come on, Chris, you can do it. NXP. And so all 6 of those we've tested. There are some slight things you might have to change in the example in terms of include list or similar, but or maybe if they have a binary for their Bluetooth HCI, that sort of thing. But that's just the 6 that we've tested. There's actually another, I think, 5 to 10 that are Bluetooth based that are in Zephyr that you could try as well. So really anyone trying Bluetooth in Zephyr, you should be able to go with this and get something working.
Yeah. I always run the Bluetooth observer sample from the Zephyr tree, and every device that I've gotten to run that example can also run Golioth without any other changes.
Yes, right, exactly. Yeah, it is. You do need embed TLS as well, right, to encode this stuff and things like that. But a lot of this, all of the
Yeah,
elements will be in
I suppose I haven't
subroutines.
tested the certs on all of those devices yet.
Yeah.
You also need somewhere to store them, but
Mhm.
I think that that's pretty doable. We're using LFS and the storage partition, and I'm pretty sure all those devices we tried out have those available as
Yes.
well.
Yep. Yep. Awesome. Well, is there anything else we should show off, Mike, or is that? I guess we're also we do have a comment section if people do have questions, and we can always be reached at forum.goliath.io. If you're watching this after the fact, this is going to be archived on different spots, so we'd love to get questions over there as well.
Yeah, I mean we can pop off a little early, or if we want to make this longer, we could like try to send some actual sensor data from the teak up to the cloud. It just depends on how cutting edge you want to get here.
Ooh, well, that's up to you, Mike, because I'm just an observer here. The mic already set up on the teak. It has a TMP 102 and an LAS2DH12. Those are those are actually already. If you're on the sensor shell, I think it's already enabled, right? So
Yeah, it
I've been
should
able to
be
see those
enabled.
readings. Yeah.
Let's see.
While Mike's
See
looking,
if I
I
can.
will also talk about the other things that are on board. So the LED matrix that Mike wrote a driver for, that's the IS31FL3731. That's the driver that drives 105 LEDs. Mike wrote a driver for that. We also have 2 motor drivers on the output, so you can drive small DC motors or one stepper motor. There is NFC on board because of the Nordic NR52840 chip. What else is on there, Mike? Let's see, just looking real quick. There's actually switchable power, so if you wanted to shut down all of the downstream components, you can also do that. And there's also a quick header, which may or may not be wired backwards, but you can reconfigure a cable, and it makes it extensible for I2C. So if you have other quick-based components, I really like this one. This is an Adafruit board that they call it Stemma, but this one is a little slider. It's like a mechanical slider that actually lights up, and it'll just send back the reading. So if you wanted to, have that plugged in, that's also pretty great. So.
I don't have J-Link connected up to this teak right now, so I think maybe we should save this for a future live stream when we
That's
do a
great.
little
That's great.
leaf node hacking.
Leaf hacking. I like it. I like it. Yeah. Yes. Lots of other things. We're always looking for other. People have business use cases, demo ideas, anything you need us to try out for you. As Mike showed, it's very flexible, very fast to get up and going, and we always love to hear about ideas that would enable people to move forward with their projects. All right, Mike. Well, thanks for the great demo. Thanks to everyone who showed up here. Thanks to everyone who's watching after the fact. Again, you can ask your questions over at forum.goliath.io. You can also reach us on social. This video is being posted on LinkedIn and YouTube. We'll be watching the comment sections there as well, but the forum is going to be the best place. And we'll see y'all in the next one. Hope everyone in the U.S. has a great holiday weekend, and otherwise has a great weekend. Thanks so much.